This is Onshape for Makers, where we are learning to create models for the shop. The part today is from Too Tall Toby's high-speed modeling contest. It's on the tootalltoby.com website and the YouTube channel tootalltoby.com. The part is a bit interesting. It is not near as simple as you would think. This is a round disc. It has a concave in it, and it has a line right here. This line determines the length of that by the way the part is dimensioned. All you get is one dimension and one angle, so if you miss this line any at all, the part's not going to work. Also, the material is steel. The tolerance is 0, so any deviation whatsoever and you're pretty much toast. This is the drawing they gave the guys to model with. It's a mess of a drawing on purpose. The break line right here is called a sharp. It's right here, and what we have to determine is this one point, because that one point sets up the 100 millimeters, which is a distance from here, and then it's just geometry, and if this is off any at all, there's no way you can have a right-sized part to finish. The other little wonder is this thumb indent. If you'll notice, it's 42 on the top and 43.5 on the bottom. So the break line is not a vertical cone. It's more of a conical breakout like you'd get with a punch and die setup, which means we have to construct this, as you can see here, a little bit different. Otherwise, we'll be out of tolerance again. This part gave the high-speed guys a lot of trouble, so we'll see if we can get through it or not. Here we go. Okay, this is the part I built to figure out how to do this. If you will notice, this break line right here is offset, which means we have to construct this differently. The other thing is we have to get this point correct, because if we don't get that point correct, there is just no way to get the right dimension from here to there, and that's all we're going to get. So let's start in a new part studio and see what happens. We are in the hamburger menu, in the workspaces, in millimeters and grams. Starting on the front, we will do a sketch and go normal to that. And then I'm going to use a center point rectangle, and just like that, and the distance on that would be the circumference of 63. And the thickness of the material is 4. Now I'm going to hit Q to get into construction line mode, do another rectangle off the center line, and it will be, the inside of that is 42, and thickness, I just need a marker. I don't really need anything. Now this is the section view of the washer. So what we need to do is go to a 3-point arc. We'll start here, go to there, come down to here, and this will be the top arc. We need to offset this using offset, and it will be 4 millimeters. And I want to draw a line vertically through this somewhere, and that gives me a half to do a revolve with. So what we're going to do is we're going to revolve this and that will become our part for our first part. The revolve axis, of course, is the corner. Click that, change the color of the part so you can see it better. And this is where we start. That was pretty easy, but if you try to do it the other way and have concentric circles and etc., you're going to come up about 2 grams off of where you want to be. So let's pull back and get on this surface and do a sketch right up here. And what we want to do, we want to sketch the notch out. So I'm going to just rectangle, that's the easiest way. The notch is 26 wide. And this depth from here to there, I don't care, but we do have a dimension from here to here, and nope, come on. We have a dimension from here to there, and that dimension on the drawing is 58. And this is the part we will be taking out. So we're going to go to Extrude, Remove, green check mark, and there is our notch. Okay, what I need is a line where the plane intersects this so I have a starting point. So I'm going to go and start a sketch on the right plane, and then I'm going under Use, you'll find Intersection Tool. I'm going to select that, and this is the cut line where the plane intersects the surface of the part. And I'm going to go all 3 sides, and then I'm going to hide the part and escape and clean that up since I don't want it. And this is the mating surface of where the lever connects to the thumb point right here. So from the drawing, we know that we need a construction line, and the distance from the construction line to here should be 15. And we also know that we need a line 100 millimeters long. And it needs to be at 25 degrees. And that becomes the top of the lever. We also need a line that is perpendicular to this line down to here, which makes the rest of the fold over side for the lever. So I'm going to pick a point, and as long as I am normal or perpendicular to this line, I will get an orange highlight. So by doing this, I am sure that I'm at 90 degrees to that. Now I'm going to come out here, and I'm going to draw a line that's going to be normal, and it's going to come down, and it's going to mate with that. There. When I come out here, I should have a point with a yellow line and a yellow reference line up at the top. And then I can draw back to here, and I have a closed surface. Why do I have a blue line? Oh, I have a blue line because I need to dimension this dimension, and this dimension is 100 minus 94, at least according to the blueprint. So that gives me that fixed corner. I'm going to go ahead while I'm here, round this corner. That corner rounds to a 7. I'm going to come down, and I'm going to round this corner, and this corner rounds to a 16. And then I'm move the dimension out of the way, circle for a 13 millimeter hole. And that's everything except the side view of the thickness of the top. To do that, I'm going to offset this 4 millimeters. And this is the side view of what's going to be the top. You'll see it in a minute. Now I need to solve the problem of these two not actually matching. And the way I'm going to do it, I'm going to go to use the extend command and pull this out. And then I'm going to use the extend command and come down to that line. And then I can kind of clean that up. But this will be the tab that connects the lever arm to the thumb dimple, whatever. We'll turn our part back on so we can actually see what we have done. And now all we need to do is extrude this. And to do that, I'm going to set it this way. I'm going to extrude this whole face, and it's going to be 4 millimeters thick. I'm going to extrude it in the opposite direction. And now what I need to do is I need to offset this, and the starting offset should be, if the top is 40 wide and I want half of it, I will do that. And that will give me half of it. And the only thing I don't want to extrude that. Now I will turn my sketch back on and take this area, extrude it over until it touches the surface we just did, and it becomes the body of the part. While we're here, we will go to the fillet command. There's a 6 millimeter fillet right there. And there is a 2 millimeter fillet on the inside. And that's a check mark. Now we need to extrude this little piece, and it extrudes 20 wide, which means it should be 20 divided by 2 because we're only making half of it. And we want to do an add and add it to this part. And that gives us half of the lever. If we come up to the mirror and select that part and do that mirror plane and do a check and do an add and do a merge all and do a check mark, we get a complete finished part. If we want to double check it, I know what the answer to it is, so we can go to Assign Material. I do not have the custom library loaded, so I will have to do this the hard way. 7.8 times e to the minus 3. Yeah, that didn't work. I think it's just e minus 3. There we go. And too tall Toby steel, check mark, and then I can ask it for mass properties of that part. And the answer, if you get the right answer, should be 408 point something. I got 0.1, but that's close enough. 408 is a round off, and that is the correct answer in the contest. The part's not hard, but it can get weird if you let it get on top of you. Hope you guys have fun. Talk to y'all later.